Spacefare. Welcome to WTUFO. I'm Caleb Mayo. This show is brought to you by you, the viewer. So thank you for supporting us on patreon.com/WTUFO, patreon.com/WTUFO. Also, you can do that on YouTube if you can figure out where, and Buzzsprout, likewise, using your research skills. Patreon.com/WTUFO or YouTube or Buzzsprout, depending on how you'd like to support us. As little or as much as you would like to per month helps the show continue to exist. So thank you again for bringing us all WTUFO. We really appreciate your support, and we're having a great time making the show. What the UFO? I'm here with Dr. Jacob Haqq Misra. Nice to meet you, Jacob.
Thanks for having me, Caleb.
Thank you so much for joining us.
Absolutely.
Dr. Misra is Senior Research Investigator at Blue Marble Space Institute for Science, and he describes himself as an astrobiologist interested in understanding the origin, distribution, and future of life. His research includes the study of planetary habitability, extraterrestrial life, environmental ethics, and space settlement. Very cool brief you've created for yourself, Jacob.
No, thanks. I mean, I have a lot of fun doing what I do.
It sounds like it. And you may have seen Jacob in various media appearances, most notably among notables, the PBS Nova special about UFOs that aired in late 2024. I thought we could maybe start with just a bit about your bio. What did you come up studying in your undergrad, your PhD? I heard you say you got a postdoc in ethics, which is a pretty interesting addition to your CV. And then maybe we could talk a little bit about your recent book, Sovereign Mars, and wind up with what you're doing right now. Sound good?
Sounds great.
Okay.
So yeah, I can just give you a little bit about my journey here. When I was a kid, I wanted to be a space scientist before I even knew the word astronomer. So I mean, it's just kind of always been in me. I went to college at the University of Minnesota. I studied astrophysics and computer science. I was initially interested in cosmology, which is a really cool field also, just the origin of the universe. And I liked computers and computer simulations and did some projects on that. Jill Tarter from the SETI Institute, who's been a pioneer in the field of searching for techno-signatures, gave a talk at our department colloquium. And I learned the word astrobiology. I had heard of SETI, but I didn't really realize how it was situated into modern astrophysics. And I thought that was really fascinating. And I found a summer internship in astrobiology that year, working with Professor Jim Casting at Penn State, who studies planetary habitability, habitable zones, thinking about how you would use telescopes to look at exoplanets for signs of life. And I was hooked on that. So I went to Penn State for graduate school. My PhD was in meteorology and astrobiology. Meteorology, I was kind of the oddball in the meteorology department, but it was to learn how to use these computer climate models to think about Earth through time and Mars through time and exoplanets, and use those tools to think about how we could search for life. And so, yeah, that was my PhD. And then my postdoc was at the Rock Ethics Institute, also at Penn State. And that was focused on environmental ethics, specifically thinking about climate change and geoengineering specifically. Like, should we be altering the planet on a global scale as a way of mitigating climate change, which I don't really think is a great idea, but it's interesting to think about. And there's even a connection to thinking about techno-signatures. What if an alien civilization did that? But yeah, so that's kind of how I got here. And then I'm one of the co-founders of Blue Marble Space. And so I've been enjoying, a combination of, some business management as well as pursuing my research within our nonprofit.
Wow, that is so cool. I'm a huge fan of all the things you've decided to do with your life. Thank you. Can you take us through a day in the life of an astrobiologist? What kind of stuff do you work on right now?
Sure. Yeah, the projects I'm working on now. So one is a team led out of Johns Hopkins University. It's most of what I do ends up being funded by NASA. There's some other funders that get involved sometimes, but so we're thinking about not just searching for what kind of planets might support life, specifically focusing on red dwarf stars and planets around them. So just in brief, the sun is a yellow dwarf star, or we call them G dwarfs, but it's a yellow star. Red dwarfs, M dwarfs, we call them, are much, much smaller, but they're much more abundant. About 70% of the stars in the universe are these red dwarf stars.
Hmm.
And so they're also the easiest place with the telescopes we have to look for kind of Earth-sized, potentially habitable planets. So it's worth asking ourselves what would make a habitable planet around one of these stars? What would we look for? And one of the key features is these planets that would probably be habitable, potentially habitable around M dwarf, red dwarf stars would be tidally locked. So it's the same way that we see the same side of the moon as it orbits the Earth. The moon is tidally locked around Earth so that the same side faces us. So that would be true for these planets. So one side of the planet would always be facing the star. So you have a point of perpetual daylight, and then the opposite side is perpetual night. And on the edges, you have, perpetual twilight. It's actually called the Terminator region. And so, yeah, we think about, so using our computer models, theoretical climates that might exist, and then you working with observers, how might we actually search for these? And when we're getting data in, just starting to get data in from things like the James Webb Space Telescope that can really help us push this search forward.
Cool. Are you saying that tidally locked planets would be better at supporting life, is the theory? Did I understand?
Well, we don't know just how, it's different from Earth. So that's one of the things with astrobiology. We have a sample size of 1. We know that life happened on Earth. So it's possible that planets like Earth around yellow dwarf stars are the best place to support life. But we don't know because we don't have any other data. So, some people argue that those tidally locked planets are harder for life to be on, but we don't know. So I think it's
too soon. Sorry to interrupt. Is it too soon to say what kind of percentage we're looking at in terms of exoplanets being tidally locked or not?
In terms of percentage of which ones are tidally locked, I think most of them. I couldn't tell you a percentage. I think in general, many of them have been observed to be tidally locked if they're in that tidal locking region.
Okay.
There's some cases where you wouldn't be. So, for example, Mercury is close enough to the sun that it would, in theory, be tidally locked. But because of perturbations from Venus, Mercury it's what we call a spin orbit resonance, not to get too technical, but it orbits 2 times and spins around 3 times, and so it's not tidally locked just due to gravitational interactions. So you can definitely get things like that too.
Okay. A couple other nerdy detail questions here. One, red dwarf is a status that we think our sun will achieve someday. Is that right? Like after it expands, contracts, goes through stuff, it'll be a red dwarf. Is that right or no?
Not quite. No. So the sun will expand into a red giant.
Okay.
Which is kind of an old age star, a retirement age star, so to speak. And then it will. It'll collapse into a white dwarf.
White dwarf. Interesting.
Yeah. So a white dwarf is like an elderly star. A bigger star than the sun would go supernova.
Okay.
And then after the supernova, you're left with a neutron star. For a really big star, you'd be left with a black hole. But for a medium-sized star like the sun, it doesn't go supernova, and you're left with a white dwarf.
Okay. So this was news to me that most stars that we've observed are red dwarfs. And that you said in the universe, right? That's
about
most
70%. Yeah, it's about 70% red dwarfs. I think about 10 or 15 or 16%, I forget the exact number, are like the sun. And then there's stars bigger than the sun. But yeah, there's a lot more of the smaller stars than the bigger stars.
Interesting. I'm so curious about this bigger stuff. I have one kind of stupid question in this area.
Okay, anything's fine, yeah.
Please forgive me, but I'm curious about the term solar system. Is that a phrase that you use specifically about our star system, or would you call any star system a solar system?
That's a great question. The technical name for our sun is Sol. And so that's what we don't ever think of a sun having a name, but the planets all have names. The sun is Sol, and so it's the solar system. And so for other ones, you call them extrasolar systems or planetary systems, or you might refer to the star, the Alpha Centauri system.
Okay.
TRAPPIST-1 system. So yeah, ours is the solar system because that's the name of the star.
This is great. So if we all want to be pedantic, we can say, actually, it's not a solar system unless it's our star. When people
technically, yeah.
Great. Love a nerd rule for conversation. Thank you. I went a little far afield there. Let's talk about your book, Sovereign Mars, your recent book. It sounds like maybe your ethics of geoengineering work might have played into this. I'm sorry, I haven't had a chance to read this work. Would you like to talk about it a little bit?
Absolutely. No, I love to talk about it. I'll try not to talk too much about it. But yeah, Sovereign Mars is really a work of political science from the view of an astrobiologist like me, because I'm not trained in political science. I did study ethics. And it was that path that got me to thinking about this question. Really, the question that motivated it was, who owns Mars? We have private companies thinking about going to Mars, like SpaceX. We have government agencies planning on sending humans to Mars in the coming decades. And I just started thinking, who owns Mars? And then I realized the better question is not actually who owns Mars. It's what does sovereignty mean on Mars and in space? And in sovereignty being a political entity like a nation state having political jurisdiction over a region. And so what I quickly realized is, just to answer the short version of my question, the Outer Space Treaty prevents sovereign appropriation of space or any celestial bodies. So you can't claim the moon or Mars as the 51st state of the United States or a new province of China or something like that. Mm-hmm. But also in the Outer Space Treaty, you keep ownership of your stuff. If you launch something into space, it retains jurisdiction under the country that owns it. And same with the people, the citizens of the US that are launched into space remain under jurisdiction of the United States. And so if you build a settlement on Mars, you might not really be claiming ownership of that land, but you're occupying that land and the stuff itself is still under jurisdiction of some nation on Earth. So you are going to have problems like this. So just to quickly kind of summarize what I did with the book, it's looking at the history of sovereignty on Earth and then drawing positive and negative examples of what I call cooperative sovereignty. I didn't coin the term, but I liked it when I found it. Mm. This is you have sovereign nations on Earth not ceding their sovereignty away, but finding a way to work cooperatively in a way that doesn't undermine their own sovereignty. And so there's examples like the Outer Space Treaty. I look at the Convention on the Law of the Seas and the Antarctic Treaty System. I kind of do a deep dive into those. Mm. And then I draw upon those to give some sort of positive and then also negative recommendations for what has worked in history, but what doesn't work is probably even a stronger constraint. For example, most countries don't like when there's a new sovereign entity that emerges that you then have to recognize as you are under the jurisdiction of them. So it might be nice to think like, oh, let's have a world space agency that can make sure we do everything right in space. Like, nice idea, but you're not going to get all the major space players to agree to that. So we have to do something different. And then in the last part of the book, I kind of get a little more idealistic, where I stick to my constraints that I think are pragmatic given the realities of history. But then I think about like, okay, well, how would you have, a sovereign Mars, a Mars as an independent, juridical peer to Earth, where these are independent planetary states. And, could you think more proactively about doing that, even given the realities? And I'm not saying that this is going to happen, but I think it's a good thought experiment to do before we get to Mars.
Very cool. How bullish are you on terraforming or bearish?
I think terraforming is a mixed bag. I think it could work. I think there's some great work that some my colleagues are doing. Edwin Kite at the University of Chicago has been doing a lot of really great pioneering work on just thinking about better, more efficient ways to do terraforming. Mm-hmm. I don't know that we should be just going gung-ho with terraforming. I think first we should keep searching for signs of life on Mars, even if it's microbial life. We don't want to contaminate that record. It could already be contaminated based on robot activities, but doing the best we can. I think we need to finish, do a better job exploring Mars first. But yeah, I'm kind of ambivalent with terraforming. I think terraforming is a long-term activity. and we're not great at long-term projects on Earth in general. So I think we would do well to practice, intergenerational management on Earth before we start engaging in sort of intergenerational projects in space like that.
It's interesting. What comes up for me there is that that used to be a skill that humans had. We built cathedrals and temples and pyramids that took multiple lifetimes, maybe 400 years, some of them. I guess they just finished the Sagrada Familia in Barcelona. I think they finished it, and that was a multi-generational project. But it is rare, and it's not something you think about in terms of contemporary human life. Like the Empire State Building was built in like a year or something.
Right. No, I mean, I think there are a bunch of examples. I even talk about that. I have a chapter in my book called Deep Altruism, where I think about not just what are some of these projects that occur over deep time, but are there projects that you could think about doing not for immediate gain or personal future gain, but for sort of broader benefits to future descendants, where the benefactor may not even be the one receiving any of the deliverables from that project. And so, yeah, there are definitely intergenerational projects that have occurred. The further out you go into, geologic time, out to, 1,000 years or 10,000 years is really what you have to think about if you're really talking about planetary management. But I mean, these are aspirational goals. Like certainly doing things over a century or two is a great start toward those longer term asaspirations.
I heard you mention the Clock of the Long Now in another interview, which is an ongoing long-term project to build a very slow, very long clock. And you said, I think, that you felt this is a reasonable use of private funds, maybe not the greatest public investment, but something people should consider worth doing. Is that an accurate description of your position? Yeah,
I would say so. I don't think the National Science Foundation necessarily needs to be funding that, but it is I think, it's sort of inspirational, but it's also a very good technical challenge to see how you could make a physical device that's going to maintain, sort of technical accuracy and functionality for, 1,000 years, 10,000 years, or even longer. So we do need to be engaged in projects like that. And of course, that's a fun one that can inspire people. The stakes are fairly low and that nobody's survival is at stake. But like, what if you need to make a settlement on Mars that's going to, maintain habitability for centuries or something because, the serviceability is not very fast? Or, what if you want to send a mission to another star system where there's no serviceability at all? So I think it's a good testing ground for just thinking about that kind of intergenerational management for, when we start doing other kinds of projects in the future that are where the stakes are higher. I'm interested in your geoengineering expertise, just sort of tangentially, but because you mentioned it and you're the first expert I've ever talked to about it, I heard your sort of registered trepidation. I wonder if you might be willing to share what you think might be some of the better, more likely ways that we could potentially geoengineer Earth if we were going to take some action in that direction. Sure. Yeah. So I think the idea that worries me the most is solar radiation management. That's where you put aerosol, dust up in the upper atmosphere of Earth to reflect away incoming sunlight. And part of the problem is once you do that, you're committed. So if you start putting aerosol up in the stratosphere and we're not turning down the knob with CO2 emissions, we keep having aggressive emissions, then you have to keep the cooling aerosol going, because if it disappears, which could happen due to, say, political instability or something, then actually the rate of warming becomes even worse. So that's the danger with that. But probably a better way is carbon capture. People have been exploring this. You could build big CO2 collectors, and you trap the carbon dioxide molecules in aerogels and other things, and then maybe you could make them into bricks or something and store them at the bottom of the sea. And there's a lot of efforts going on to develop carbon capture technologies. I think they're kind of energetically expensive.
Mhm.
And so that's really the trick. You don't want to put more energy into capturing the carbon than you're saving by removing the carbon. So there's that trade-off. There's people that talk about like marine cloud brightening and things like that. I think that's a middle ground. You're going to have other effects on the climate system once you start, modifying clouds. We already have cloud modification and farms, try to do cloud seeding to get extra rain. And so we're already geoengineering the climate in that sense where we, perturb the cloud system. So I think there's maybe some ways like that are less harmful, but they're all interfering with the climate system. And so I think the reality is, we have a changing climate. We are emitting carbon dioxide. There are renewables and other technologies available. There's nuclear fission, which I think needs to be a part of the conversation. Nuclear fusion is even cleaner, and that is up and coming. They recently showed a net gain in energy from nuclear fusion and in concept. So I don't know how long it'll be till we have a fusion plant, but that's a good direction to go. So yeah, I think maybe some of those geoengineering solutions could be a part of the trajectory toward climate stability, but I don't think they're going to solve the problem for us.
Interesting. Okay, thank you for indulging. I mostly discuss UAP on this show, but I'm starting to think that there's a bigger picture of improving the planet that kind of goes along with interaction with UAP. And I'm going to tiptoe us toward that topic, but I'd like to make 2 or 3 more waypoint stops on our way. But getting a little bit closer, can you talk to us a little bit about SETI, the search for extraterrestrial intelligence? Maybe distinguish that from the search for techno-signatures, and then maybe we'll move on to METI a little bit and do some more astrobiology. Is SETI its own world? How do you feel about the state of research now? And do you see it paying off in years ahead? Do you think it needs to be changed or incorporated into some other disciplines? How do you feel about SETI these days?
Yeah, absolutely. So in some sense today, SETI and techno-signatures are synonyms, but there are differences still, especially in the way a lot of people think about it, and certainly the choice of word that a community uses does reflect something about its origins more so. So traditionally, SETI, the search for extraterrestrial intelligence, has been primarily focused on using radio observation. So looking for radio signals from other star systems, and now you can think about other planets around those stars that would be directed toward Earth, or leakage radiation from their communication that would tell us that there's an extraterrestrial civilization, extraterrestrial technology in that system. SETI also does some work in optical signals, so like laser pulses, but similar to a radio beacon that might be beamed toward Earth. And so there is great work going on in SETI. I think it's worth doing. There's been recent investment by private foundations like Breakthrough Listen that has contributed over $100 million for over 10-year search to do like all sky surveys to look for anything that might corroborate the SETI hypothesis that there's radio signals coming from extraterrestrial civilizations. And the amount of searching that's been done is still relatively small. The analogy that's been used is, if you're in the middle of the ocean and you dunk a water glass into the ocean and you ask yourself, are there any fish in the ocean? You look at the glass, there's no fish. Well, did you prove there's no fish in the ocean? Well, of course not. But it also wasn't a terrible experiment to do. You might have got a fish, but there's a lot of ocean. And so you have to do that a lot before you can convince yourself if there are or aren't any fish. And so at this point, the search has expanded to about like a hot tub's worth of the ocean. So it's good. That's progress. There's still a lot of ocean left to search. So I think we can't rule out the idea of a radio signal, although with the searches that have been done, you can probably rule out the fact that there's very, very loud, omnipresent, strong signals being beamed directly toward Earth.
Okay.
But whatever's going on, it's got to be a little more intermittent than that, because otherwise we would have noticed something that obvious.
That's good to know.
Yeah.
How do you feel about the WOW signal? This is an event in the 70s. You could probably explain it better than I could, actually.
Yeah. The WOW signal, it was an astronomer at Ohio State University. And it was, they were doing these radio SETI observations, and then there was a big spike in the data, and the observer wrote WOW and circled it, and that's how it got its name. And it was never repeated. And people have looked since then in the same direction. There's never been a satisfactory explanation. Most of the time in SETI searches, radio SETI, you get a lot of these false positives, and sometimes they get attention, and you have to track down what's called radio frequency interference. What process on Earth was causing this? And a lot of times you're like, oh, it was a microwave that someone had turned on, or oh, there was a satellite flying over. In the case of the WOW signal, they were never able to convincingly corroborate it with radio frequency interference.
And one reason I heard for that was that it had something to do with the time of the signal, like the length of the signal was the exact amount of time it took for the array to pass into like functional observance of this space and then pass out of it, and that suggested strongly that it was an extra Earth source.
Right, yeah, exactly. So there was reasons to think that it was consistent with what you might expect an extraterrestrial signal to look like, but because you couldn't repeat it, it was very, very difficult. I mean, it's been impossible to really attribute that to extraterrestrial activity. So that's what SETI searches in the radio and optical really need, is not just a signal, but a repeatable signal that you can then study. If it has information content, even better. But even if it doesn't, if you find a repeatable signal, that at least tells you there's something going on there that you can study. And so that's the big challenge.
And there are natural phenomena that can produce signals, right? Like would it be the case that there are natural phenomena that can produce radio waves of the type that the WOW signal consisted, like, I don't know, neutron star collisions or supernovae?
Right. I mean, the WOW signal in particular, I think people still argue about what else could have caused that. But yeah, neutron stars, we mentioned, are an excellent example. So, neutron stars are the end state of a bigger star than the sun after it goes supernova. And neutron stars pulse, and some of them rotate really fast. And they do generate a pulsed radio signal that's so accurate you can use it to set clocks if you want to. And
as in repeating in a
that's right. Yeah, it's just like this pulsated radio signal.
Okay.
And when these were first discovered, the astronomers who discovered them, I think they later won a Nobel Prize for it. But internal discussions, they referred to these as LGMs, little green men, because they didn't know what it was for a while.
Okay.
And there was discussions like, do we let people know about this before we have a good theoretical understanding of what this is? What if it is little green men? And this was a huge advance in understanding stellar evolution. But it's evidence also that a periodic radio signal doesn't immediately mean it's extraterrestrials either. There are phenomena in the universe that can do things like that.
This is one more kind of ignorant question, but on the WOW signal, is the data of a quality that you could feed to an AI, for example, and say, can you tell us anything interesting about the signal? Could you try to pull a pattern out of it? Or does it not really work like that? And the data is just like a line on a piece of paper?
Just because it's a one spike in time with no repeatability, you just can't really learn anything from it.
Okay. So it was just like, there was more of this signal here for this much time, and that's all.
That's all you can really say. Yeah, unfortunately.
Okay, that's good / disappointing to find out.
Yep.
So we were saying that traditionally SETI has been this search for radio signatures, and you're sort of implying there that it might be expanding these days. You mentioned that techno-signatures are kind of becoming a part of SETI, although it's you sort of implied that the communities don't all use the same language in this space.
In that sense. So I think SETI is a search for techno-signatures. So a techno-signature is just observational evidence of extraterrestrial technology. So in that sense, techno-signatures is a better term because you're not searching for intelligence. My cat is pretty intelligent, but my cat doesn't emit, periodic radio signals that can be detected across space.
That of.
Yeah, that I know of, right. Whatever she's doing at night. But and of course you can go through Earth's history and find plenty of examples when Earth had intelligent life, human intelligent life, but was not emitting radio waves, for example. And so what SETI is looking for is really extraterrestrial technologists. And so they're looking for techno-signatures. But we also use the word techno-signatures now as a subset of biosignatures. So one of the things we do in astrobiology is we look for habitable planets and what kinds of signs of inhabitants of life on some of these planets might we look for, things like oxygen in the atmosphere and methane and things like that. And so a subset of a biosignature is a technosignature, which is, not just things made by life in general, but things made by life that produces technology. So atmospheric pollutants or city lights or things like that radio telescopes weren't really equipped to do. But now that we are looking at exoplanets and we're, on the cusp of being able to characterize the atmospheric gases in some of these terrestrial exoplanets, we can start to say things about, does this planet look like the kind of planet that might have life, the way that Earth would look like at a distance? And then similarly, does this planet look like it might have technology the way that we on Earth have made large-scale alterations to our atmosphere from our technology? And so a technosignature, in that sense, just broadens the scope of what you can look for beyond radio and laser pulses to anything from atmospheric pollutants to satellites orbiting the planet, or anything like that. Flashes from fusion drive in the system if you're so lucky to catch one. So it's really allowed more of astrobiology to engage in the search. And then, what I'll add is the show's about UAP. We also can think about looking for technosignatures in the solar system. We think about looking for biosignatures in the solar system. There are missions on Mars that are designed to look for signs of either extinct or present life on Mars, mostly thinking about microbes. We're not really looking at aliens that are walking around on Mars at this point. But certainly there's many places in the solar system we can't rule out the possibility of life, the oceans of Europa or in Titan or things like that. So there's a lot of astrobiology work doing solar system exploration to look for organics, microorganisms, things like that could be living on other planets, other moons in the solar system. So similarly, we can still think about about looking for technosignatures within our own solar system. Again, I'm not saying there's a city on Mars that we haven't found yet. We've mapped all of Mars. We know that there's not a big city that we've missed. But if there is extraterrestrial technology that has been sent here from another star system, just like we have sent, a handful of probes outside of the solar system, if there's any exploratory probes that have been sent here, that's certainly worth looking for. And this could be something sent recently that's still functioning. It could be something that was sent a long time ago that's drifting through space, that crashed onto the moon, crashed onto Mars, anything like that. But the search space has not been constrained very well. So it's worth looking. If you find something, well, that's one of the biggest discoveries ever. And then, of course, if you don't find something, but you do a good job in searching, you can at least say something about what's not there. We mapped the moon. We did a really great search. We found no evidence of artifacts down to this size. Okay, so you've made progress in the sense of ruling out some hypotheses. So I think that's also worth doing as we look far out for technosignatures on exoplanets. We should also be using just the tools that we have for exploring the solar system that are already there to try to look for technosignatures in our solar system.
So much here. One, I want to put a big pin in the value of searching for stuff, even if you don't find it. But I want to ping three other little ideas here. One, technosignatures in the solar system could potentially be archaeological. There have been a couple of little hints and possibilities of maybe that looks like a corner or a square on Mars, or there's a really weird rectangle on Ceres, I want to say. But I was curious if any of these have tilted one eyebrow even slightly up for you.
Those sort of morphological features where, you see something angular in an image, they usually don't hold up because once you just look at finer resolution, you realize oh, it's a jagged rock. It just looks angular. at the way, the resolution that picture was taken. Was taken.
Is there any one of these that you would want to go send a probe? If you had, probes at your disposal, would you go check out this rectangle on Ceres or the square on Mars? Or
probably not. No, probably
even
not. I think those are probably false leads. Yeah. But you are right that archaeology is a way that we could be looking at this, and there could be, if an extraterrestrial spacecraft, say, crashed onto the moon or Mars or something, it could be buried, or even in one sense, it could have come a long time ago and broken apart, and there's parts of the spacecraft like metals and elements that have been bound up into other rocks that are now in the solar system. So you might find what we call a geochemical anomaly, something bound up in meteorites that came from something very, very ancient, but technology still. And that would be something that we couldn't explain through other geologic processes. So we do need to be, thinking creatively about that. And what I would say is we don't need to prioritize things that, look angular at a distance. But if you're going to study those anyway, and you've got a probe that's going to be there, then it's worth asking the question. Whatever we're searching for, and that's one of the things I think we can do with techno-signatures in the solar system, is we don't really need to dedicate too many extra resources to that, but we can use the fleet of rovers and orbiters and probes that are already doing this work. There's already data sets, and just ask those questions and do some extra analyses to see what might be there. And again, if you don't find anything, then at least you still learn something about what's not there.
I thought this was one of the more valuable contributions of the NASA study report about UAP in late 2023. I'm sure you read it. And one of the things they say is there's a logical continuity between the search for extraterrestrial intelligence elsewhere and looking for techno-signatures closer to home. The paper proposes some really interesting ways that we might go about getting more data. I think it was sort of like widely misreported as NASA says no UFOs. And that was not the point of the study at all. It's not a deep dive of UAP research. It's just a proposal of some ways we might get more data. Does that square with your feelings about this paper?
Oh yeah, absolutely. That the NASA panel was commissioned just to look at, could NASA make any progress on this field. I actually was invited to give a talk about solar system techno-signatures to the panel, which is
wow, cool.
And so I definitely said a lot of what I just said to you about how NASA and other space agencies could leverage their existing suite of tools to look for technology in the solar system. But yeah, nobody on the panel was looking at data to see if there are UAP or not. It was really a very high level. The amount of money that went into this was very, very small compared to other things that NASA does. So it was just enough money to convene experts to meet a handful of times and just assess NASA's capability to study the problem, but not actually to conduct any research on the problem. Yeah. Which is, science sometimes moves slow. And the media definitely didn't quite get that right all the time.
Thank you. I agree with that assessment. I believe they appointed a UAP head, and that person eventually left the agency. I don't know if they replaced them. Maybe you know more about that.
I'm not sure that they did replace them. I haven't heard about a replacement. And yeah, it was a little disappointing.
Maybe it should be you.
Yeah, I think they... from what I understand, there is this sort of, publicly NASA has convened. It was at the behest of the NASA administrator at the time to convene this panel to study the capabilities of NASA to contribute to UAP science. But within scientific communities, which can include people at NASA, there tends to still be a resistance toward taking this problem seriously. Yeah. And so I don't know where, those cultural biases contribute toward appointing or not appointing a new UAP director. I think Jared Isaacson is going to have his confirmation hearing soon. I don't know how he feels about the UAP topic, so we'll see. But yeah, there's still a little bit of push and pull among scientific communities, including within NASA, on just the extent to which this topic should be taken seriously.
I find that extremely interesting. It sounds to me like you are in the Avi Loeb camp of why not at least check this stuff out. Does that sound right? Would you associate yourself with Dr. Loeb's interest in exploring possibilities like Oumuamua being a probe, and whether or not you have an opinion on, that status? It sounds like you think it's worth checking out, at least to some small degree. Is that right?
Yeah, I do agree with that. I mean, so I'm a research affiliate with Avi Loeb's Galileo Project, and
Great.
so I attend their monthly team meeting. So I mean, in that
cool.
sense, yes, I agree with what he's doing. Worth asking the questions. Yeah, as far as Oumuamua goes, I'm not convinced by any of the data that Oumuamua in particular was technological. I don't tend to argue for that, and it's long gone. So unfortunately, we're not going to learn anything more about it. But I think it's absolutely worth asking the question: are there other Oumuamua-like objects, and could those be technological? We don't know how often, an object enters the solar system from interstellar space, and if there are. I mean, obviously there are, but we have no idea if any of those are technological and how often a technological one might be entering. So, it's definitely worth keeping an open mind in terms of thinking about the possibility of other interstellar objects being technological.
Before we're too many millions of astronomical units away from this, I just want to ask about assembly theory with regard to biosignatures. This is, as I understand, is like kind of a relatively new idea about gauging the complexity of molecules to determine whether life might exist on a planet. And I was wondering if you had a feeling about assembly theory. Do you like it as an avenue for sort of logical inquiry, or are you skeptical about its value?
I tend to be a little skeptical of its value, only because I think from a theoretical aspect, it's fine. But I'm really interested in what can we search for. And, with a mission like the James Webb Space Telescope, there's been observations of the TRAPPIST-1 planetary system. And, it takes a lot of observation time just to figure out, does this planet have an atmosphere? And then you have to do even more observation. Is there carbon dioxide on this planet? And then, looking for oxygen on any of these exoplanets is really, really hard. It'll take very long, observation times to do this. So I think it's just a little bit premature to use something like assembly theory to guide the search. We really need to just think about what planets can we observe? How can we dedicate enough time to just characterize the atmospheres at all, and then go from there? So it's going to be, not even just decades, I'd say, centuries or longer before that kind of sophisticated way of looking at an atmosphere is really going to help us prioritize search targets or interpret them.
Okay. Thank you for mentioning TRAPPIST. I just heard recently that we found some rocky planets around Barnard's star, which is another one of the pretty close stars. What's like the small handful of closest. So I was wondering if you have any like personal favorites, systems that you would really like to know more about.
Yeah, no, we did. I mean, that's exciting. My favorite exoplanet is yet to be discovered. I think it's worth studying all the ones that we have, because that's what we know about and we have to learn about them. But the easiest ones to find aren't necessarily the best places for life to exist. They're just the easiest ones for the tools to have. There's a metaphor where you bump into a man who's searching on the ground underneath the street lamp, and you say, "Oh, what are you doing?" Like, "Oh, I'm looking for my keys." Like, "Where do you lost them here?" Like, "No, I lost them, down the street there, but this is where the light is." And so in some way, that's what we're doing. We're looking where the light is, where we can search now with the tools we have, which is what you have to do. So if we find a biosignature or techno-signature on a planet around Barnard's star, or TRAPPIST-1e or something, I'm going to be ecstatic about that. But I'm not putting any money on it. I think the next generation of space telescopes is going to push the frontier about actually searching in better places for these kind of planets.
Okay, taking one more big step toward UAP, how do you feel about METI? How do you feel about the state of messaging extraterrestrial intelligence? Is that a project you've been involved with at all? Are there any projects you felt were more promising? And maybe would you like to explain why you think this is not as dangerous as some people think? I heard you lay this out in another interview that we basically unintentionally METI with a military radar. We send a lot of data out. And so the argument, as I think I heard you make it, was we're not adding very much to that pile. If we were like doubling the amount of signals that we were sending out, then that would be cause for concern. But the METI projects so far have not sort of meaningfully increased the amount of signal that we're sending out from our planet. Does that sound right? Is that about?
Yeah, that's exactly right. I mean,
Okay.
METI, messaging to extraterrestrial intelligence, there's a lot of very strong emotions about this topic. And I have been involved in a couple projects. One was Lone Signal, which we attempted to have a privately crowd-funded, METI radio signal sent out to the Gliese 526 system, which we don't know if there's exoplanets, but it was just a possibility that there might be. It's a good system with potential for exoplanets. So we were just kind of speculating on that, and it was all private funding, and it was hard to sustain something like that. But it was fun, and we learned a lot about how to do a METI project. But yeah, as you say, we have radio waves going out from Earth from our communication. We have military radar. We have astronomical radar. We have city lights. And we talked about other techno-signatures. So if we're thinking about looking at extraterrestrial pollution, extraterrestrial city lights, we have those things too. So if any extraterrestrial astronomers are looking at Earth, they're going to see not just our radio waves and our radar, but also chlorofluorocarbons in our atmosphere, and night side illumination from big urban areas, and a growing satellite belt if they've got good enough telescopes to find that. So we have a lot of technology in our system that already gives away our location. Now, I don't think that METI is the best way to find extraterrestrial life. There's a lot of ifs that go in here, where we send a radio signal to another system. You assume there's someone on the other end who's listening and then can recognize the signal. Maybe there's information you encoded, then they can decode it, and then they reply and send back. So I don't advocate for NASA necessarily putting money into this, but if private money to fund something like this, I think is fine. I think there's a lot of sort of inspiration that can go along with that. I think it's a good educational project to do. And again, we talked about intergenerational projects. So this is a good one. If you send if you send a beam to a star 30 light years away, well, it takes 30 years to travel there. However long it takes, the hypothetical extraterrestrials to decode the signal, and then they send it back, and then there's another 30 years to get back. So you're looking at least 60 years from the time you transmit to when you could even check to see if your experiment worked. So I think in that sense, it's a fine thing to do to get practice with intergenerational projects, to pass the baton and keep the memory alive. We sent this transmission toward Gliese 526 in the year 2013. Let's listen now, 60 years later, to see if there's anything there.
Mm-hmm.
And so again, I don't put a high likelihood in that experiment working. I think METI is going to become more relevant if we find actual exoplanets that have tentative biosignatures or techno-signatures. Once you find a place that you think, we think there's a good chance of life being there, now the question of sending a message to elicit a reply becomes, I think, much more meaningful.
That's interesting. And at that point, would you like to see an international effort here? Because I was wondering, are you familiar with the work of Dr. Michael Bolander? We spoke to him, I think, the week before we're speaking to you.
A little bit, yeah.
Okay, cool. Well, one of his interests, he's an international lawyer and German judge, and he's a professor of international law, and he thinks about SETI a lot. And one of his arguments is that this is an act with international implications to send a message. If it were to be received, it would potentially have global implications. So it would be reasonable to conduct this action internationally, and his work has been sort of driving us toward how can we think about some kind of global body that could make these decisions, or like a treaty framework wherein, as you pointed out, the sovereign nations of Earth could at least agree upon what we might say. Does that seem like a worthy project to you? I think so far METI has been like the province of individual labs and projects that have undertaken it. Is that right? And would you see having a place as part of an international discussion?
Right. I think as far as an international discussion goes, that's good. But in terms of, trying to unify and centralize this, I think it's not going to work. And that's, one of the themes of my book is if what you're trying to do is, have a body that has unique jurisdiction over METI, I don't think you're going to get total buy-in from all the important players, just like you're not going to get total buy-in for World Space Agency. So I think whatever you have, it has to be a little looser. It has to be something like best practices, or, you have some group that has representatives from, nations of the world, for example, to sort of set standards. But I think the enforceability is impossible. It's very cheap to have a radio dish and point it at another, a spot in the sky and send a transmission, and laser pulses too are very low, inexpensive. So you're not going to be able to prevent, the diversity of voices that wants to transmit from transmitting. And so I think that is just the reality that we have to embrace that. I have colleagues that talk about wanting, global consensus for METI. Well, what else do we have global consensus about?
Yeah,
there's not global consensus about what caused the pandemic, or even should X war take place. I think if we could have global consensus on things like that, then maybe there could be global consensus on something like METI. So I think actually I don't have a problem with a cacophony of voices being the representation of Earth. I think it is also fine to have experts making best practice recommendations, so that even if there's a cacophony of voices, maybe there are resources so that, like, here's some things to think about for doing this effectively or responsibly, or here are the other messages that are going out, so you're aware of them. However you do that. But I don't think we're going to get away from a multiplicity of voices. But, the fact that we don't have global consensus on many things at all on Earth is representative of Earth. So I think if our signal to an extraterrestrial planet is this cacophony of voices, that's who we are.
It's such an interesting point, and it's also an interesting contrast with our previous guests. Thank you so much for sharing it. I want to ask if you think another underlying sort of plank of your optimism about METI here is your logical guess that advanced civilizations might tend to be benevolent. Would you like to talk about that at all?
Yeah. I think that the idea, benevolent may be a strong word, but I'm not worried about extraterrestrials finding out about us because of METI and then coming to destroy us. I can't rule that out because I don't know what's out there. That's the whole point of doing astrobiology. But a lot of these fears actually come from analogies based on human history. You have Cortez sailing to the South America and infecting people with smallpox, and having Westerners invade the Native Americans, and all sorts of horrible stories that have happened on Earth. And so yes, there's a little bit of an analogy that could be drawn. But
that was Stephen Hawking's point, or a point that he felt strongly
Stephen
about,
Hawking
right?
made this point too, right? Stephen Dick, who's a historian of astrobiology, he kind of dug into this and looked at essentially people who study analogies, and it's very easy to overextend an analogy in any case. And so in this sense, all of those cases are cases between human contact with other humans. And we know for a fact that if extraterrestrials contact Earth remotely or by visiting us, it is not human to human contact. So there's many aspects of those context scenarios that you really can't draw on too strongly. Even then, if you pull back and you look at, humans introducing species into new ecosystems or something, that's still interactions between Earth originating life and other Earth originating life. So we really have to take these analogies with a grain of salt. Again, it doesn't mean that it'll all be, sunshine and roses. We don't know. But I think we also can't presume that because contact with human civilizations that have been technologically asymmetric has always gone bad, therefore contact with aliens will go bad. Because introduced species tend to create ecological disasters, therefore extraterrestrial introduction into Earth will go bad. I think that's far too strong of a conclusion. I think if you're going to make those analogies, you also can make positive ones, that contact with new technology can bring about benefits. So, but what I will say to the benevolence argument is that if you are a spacefaring civilization that's able to traverse interstellar distances, you have to have solved some of these important problems of sustainability, how to get along. It doesn't mean you pose no threat to anyone else, but it does mean you've solved a lot of the problems that we're still grappling with on Earth. And so if you are able to survive for geologic and astronomical timescales, that does suggest that at least you have a different sense of operational ethics than we have on Earth. Again, whether or not that makes them a threat to us, it at least makes them pretty different from us, that I think you can't use these analogies between human contacts.
Yeah, I think that's a really strong point. It's sort of like a great filter point a little bit. Like if you made it into space, you passed through a great filter, you didn't blow yourselves up. The only pushback I would like to add, I think you basically internalize this, but I want to verbalize it anyway, is that it's possible to imagine a scenario where a species becomes spacefaring and is still quite dominant and maybe even warlike. Maybe you could imagine like one species conquers its entire planet, sets up like a one world government. Maybe the continent shapes are different and it makes that easier. And then it goes out into the stars because it's organized its own backyard, and it might have hostile intent when it meets another planet, or another species. So I guess the argument would be, since we can't know for sure that they aren't hostile, it is at least not without risk to wave a flag and indicate our presence. But I think you made another good point there, which is that there are potential commensurate benefits if we get it right in the other direction. If it is a benevolent species that finds us, and maybe there could be technological transfer or other enlightenment that came from that relationship. So did you have anything more that you wanted to say about that? I just kind of...
No, I mean, I definitely agree with that. The other scenario is, maybe we're like ants, and they come here and we're just like little bugs running around this planet. They have no interest in us, and you could cause inadvertent harm or just ignore us.
Yeah.
The way that you might walk by an anthill and either kick it over or just ignore it on the sidewalk. So the asymmetry could be so large that they don't even care about us.
And people have made this point about SETI and the Fermi paradox to say, we may not even be capable of recognizing the sort of structural elements of the universe. Like an ant is incapable of recognizing an overpass or something.
Absolutely.
Like that.
Yeah.
So I guess we've avoided it long enough. Should we talk about UFOs? Should we start by expanding on this idea of the value of searching? As you're in these monthly meetings with Galileo, do you feel like we're on the right track in terms of setting up some gear to look for potential extraterrestrial intelligence as associated with unidentified anomalous phenomena?
Yeah, I think what Galileo Project, and there's some other private projects, I think what they're doing is definitely on the right track. Right now, UFOs, now UAP, have been reported by military pilots, commercial pilots, other eyewitnesses, but the best cases, usually often involve aviation corroborated with, maybe radar and video evidence, things like that. But again, these are one-off cases. We talked about the WOW signal. So the same problem. If you observe a blip in the sky, even if it's a blip that somebody saw and it's on radar and it's on video, you can't learn much from it without having a repeat observation, or at least quality controlled data that you can then examine further. And then, of course, many of these are classified by militaries, and government secrecy becomes something you speculate on with this. So privately funded projects that are doing this from a scientific paradigm, I think, are the way forward. Looking at the sky with a multimodal instrument suite all the time, having calibrated instruments that are designed for searching, not just something that you happen to find an anomaly on because you were doing military surveying or something like that. We have these machine learning tools that can then sift through large data sets and try to figure out what's known and identify what the unknowns in those data sets. So we're definitely on the right track by making this a public, declassified project rather than something that's shrouded in military secrecy.
Thank you. Great start. I'd love to talk about something that sounds boring, but super important, actually, which is the question of funding. And I'm especially curious about your feelings on this since you're in the scientific community and specifically the astrobiology community. I want to set the table a little bit, and broadly, I'm going to ask, what should we do about this? But for ballpark comparisons, just back of the envelope, it looks like we've probably spent over $1 billion over the past, 40, 50 years researching string theory ideas. We've definitely spent tens of billions of dollars and maybe over $100 billion of public money researching subatomic particle physics, which is obviously great, obviously very curious and interesting. But as far as I can tell, if you take the military out of it, we have spent no civilian money investigating UFOs, as in public tax dollars. And the only exception I could find to that was France's Gaipan, I don't know how to pronounce it, Geipan, which probably, it looks like, maybe spent less than $10 million. So every time we have looked at this with the military, AARO, Project Blue Book, Condon Report, all these investigations found some persistent unidentified rate between 2% and 30%. If, as you have said, you implied this about SETI, I think if UAP turn out to be non-human intelligence, that would be one of the biggest scientific discoveries of all time, if not the biggest. So it seems to me like even a 1% chance that this might be true would seem to warrant some public investment, at least more than zero. So I'm wondering, big question, do you agree? And what do you think that percentage might look like in terms of what we should be spending? And then I have a few follow-ups too.
Well, I mean, I do agree. I think it is a problem that, large segments of the public, we can talk about the United States, but it's a global phenomenon. Like people care about this. And so if public funding is supposed to reflect public interests, then greater than zero, I think, is certainly warranted, given that there is greater than zero interest in figuring out what UAP are. So I'm not, one to recommend what the funding percentage should be, but certainly I think it would be worth expanding the funding scope beyond these kind of sporadic private investments. Although I think it's fine and great and encouraged for private investors, private philanthropists to contribute to this and drive it forward. I don't know if we're going to get there later, but I can add this now. Part of the stigma for UAP is, again, it comes back to sovereignty. I don't really talk about this in my book, but Alex Wendt, who's a renowned political scientist at Ohio State University, he made this argument that UAP, as something that is unknown, poses a threat to the sovereignty of nation states and militaries. Because if the Air Force is supposed to be aware of everything in the aerospace domain, and there are these persistent anomalies that they don't know what they are, acknowledging that there's a reality of a thing that we don't know in the sky, and we can't even say if this is harmful or not, undermines the credibility of the military. It undermines the trust of the people in their government, and ultimately it undermines the sovereignty of the nation state itself. So in that sense, there's a vested interest in governments to deny the existence of a problem. rather than to say, there is this thing that we can't protect you against that we don't understand. Let's study it. So it's better to study it in secrecy and figure it out first before you kind of undermine your own sovereignty.
That would be the military logic.
That's right. So in that sense, going after it through private means is perhaps more productive.
And there is this kind of third thing in the middle. There's military spending, and then there's private spending, and in the middle, there's basically the National Science Foundation. How do you feel about their potential role in this?
Right. I mean, the National Science Foundation is like NASA. They are a grant-making institute, at least for a lot of what they do. I mean, I think technically the NASA report did open the door, again, in a technical sense, to NASA receiving proposals for studying UAP. I'm not sure if NASA has received many. I don't know if those kind of proposals would have a lower likelihood of being funded, but in principle, one could submit a proposal to NASA for doing scientifically grounded UAP research, and you could reference this report, and in principle, that's now relevant in a broad sense to their mission. I don't know enough about NSF in terms of how they approach that topic, but one could at least try, given the precedent for NASA, and then you could say this is now grounded in science. And so and then I think I have a couple colleagues that may be trying to knock down the NSF door for some projects that are related. I think if you can tie it into other scientific objectives, you have a stronger case. So if you're going after something else that has a high likelihood of learning something,
like meteorological exploration,
something meteorological or technology development or something like that, you may have a higher chance. So I think that's certainly worth in an avenue worth going down. And I mean, there's a precedent of doing this in SETI research too. Like SETI has not found anything yet. So what are you spending all this money on? Well, a lot of SETI projects, people who get their PhD on a SETI related topic, they're usually also studying something else. So you might be looking at, rings around exoplanets or asteroid belts or something like that. And you're also searching for anomalies that could indicate extraterrestrial activity, but not finding something doesn't just tell you that there's nothing there. You've also been studying this other astrophysical phenomenon that you learned something about through your method. And so then there's still something positive to be gained from it. So, when you're using public funds, that's probably the most pragmatic way, is to have sort of a dual purpose where UAP might be one objective, but then there's still something else to be gained from spending that money.
That's a really good point. Separately, I've talked to a couple scientists about NSF funding specifically, and an argument that they've made is that the challenge with writing a grant for this organization right now is that it has buckets of money designated for various kinds of scientific research, and none of those buckets say UAP. So from a policy perspective, like from a public policy and maybe even like activism perspective, or just as a civilian who lives in this country and can express his opinion about how the government should work, would you like to see like your representatives press for some kind of like line item request from the NSF? Like I have asked my congressperson, would you support, please, a request to the NSF to create a line of grants that are specifically aimed at funding UAP research? Does that seem like a tree that's worth barking up for people who are contacting their representatives? Or is that not how science funding works at all? Like, am I in the ballpark here?
Well, one could do that. Yeah. So techno-signature research started getting funded at NASA in part because Congress took an interest in this. And it was Lamar Smith who chaired a hearing to ask, what could we do for techno-signature research? And NASA realized we're unprepared to do this. And they started actually gearing up their efforts. And that did ultimately lead to, funding for techno-signature research. Since then, NASA has a statement in its funding calls that say at the high level across all programs, biosignatures and techno-signatures are relevant to NASA's broad mission to search for life. And so that means that you could have a techno-signature or biosignature research proposal in any of the programs if you can make a relevance case. So if you want to look for artifacts on the moon, well, the Lunar Data Analysis Program now has to say that that's relevant. Now, you still have to write a good proposal, but they can't reject it by saying we don't do techno-signatures.
Mm-hmm. Okay.
So something like that
cool.
would be great at the NSF level as well, just to say at a broad level, this is interesting, because you could think about doing a UAP proposal that's more astronomy focused. You could think of doing one that's more meteorology focused. And so to have one catch-all, well, one catch-all might be fine too. I think both of these are fine approaches, to have Congress put pressure on the NSF to say, we want a specific pot of money to study this, or to say, like, we want you to just acknowledge the broad relevance of this to many types of things that you do. Either or both of those things would be a great step forward.
To put some actual numbers on this, a scientist we spoke to named Robert Powell, who co-founded the Scientific Coalition for UAP Studies, he's proposed in his book, he pitched 1%. What if it were 1 to 2% of the NSF's budget? That would probably look like $100 to $200 million a year. It seems like a lot of money, but on the other hand, sensors are expensive, people are expensive, time is expensive. So to bring it home, how do you feel about the progress that Galileo is making? Is Galileo reaching out for grants from NASA or NSF? Do they feel like they have enough funding privately? And how do you think it's going in general?
I mean, in general, my impression is that things are going really well. I know a lot of the funding is private. They may be, trying other avenues for funding. I think, every scientist is always, looking for more funding. But I'm encouraged with what I see. I mean, there are operational sites. They're expanding the network of locations where they're collecting data. It's really become a computer science problem at this point, where you've got so much data that you need to have very sophisticated machine learning algorithms to sift through all the data, identify the knowns, and see what unknowns you're left with. But I mean, this is unprecedented what the Galileo Project is doing in terms of the scale of this kind of investigation. So so I'm very encouraged.
You mentioned they're expanding sites. Are they building more sensors right now? And how many sites do they have operational currently?
I think there's 2 sites operational, and I think they're building a 3rd right now.
Okay. Cool. I had heard from some other quarters that maybe they were bumping into sort of the limits of money or time because I'm sure everybody involved in Galileo is also doing other stuff, their own research, their own professorial academic work. They're probably looking into dark matter and other stuff.
There's a couple of postdocs and at least I think a couple of grad students that are dedicated to the Galileo Project. So there are some full-time people working on the science.
That sounds really good. And you mentioned there were a couple other organizations, like we've talked to some people from UAPX who have been publishing on one of their expeditions. I think it might have been the only field study that has been conducted so far. What would you like to see from UAP research in the years ahead? If you could wave a money wand, would you just build sensors all over the world, or get more compute power for the artificial intelligence, the machine learning, scraping? What do you think are the most productive avenues?
Yeah, I think we definitely need all sky coverage for sensors. So, I mean, the Galileo Project's on the right track. So one thing you would need is a much larger, ideally global network of sensors. Leveraging satellites would be ideal. Ideally, build your own, but there's probably work that can be done by partnering with existing satellite networks. There's a need for additional theory, I think, which can do 2 things. One, it can just help propel forward. What do we actually look for? Right now, you're just looking for anomalies across the infrared, visible, radio, and I think that's good. Just what kind of anomalies can we capture? But there's clearly an interest in the extraterrestrial hypothesis. I do not put any likelihood or unlikelihood in what it is. Is it extraterrestrial or is it not? I don't take any of the hypotheses off the table either, right? But I think at this point we're in a mostly hypothesis neutral territory. I think exploring some of the hypotheses from a theoretical level and then making some predictions based on the hypotheses as to what actually to search for would then help advance the instrumentation and the actual search effort. So, that could include anything from more theory and theoretical investigation of atmospheric anomalies that arise from just terrestrial meteorological processes that we haven't thought about. It includes investigating the extraterrestrial hypothesis. When people talk about this, it's very hand-wavy in terms of the link between UAP sightings and extraterrestrial activity. Like, of course, you can think about, oh, maybe this is a spacecraft that came from, another star
Zeta
system.
Reticuli.
But why? What are they doing? What are the scenarios in which this would even make sense?
I think that's
that we can ask that question with our limited human knowledge. I think that's still underexplored. And situating that discussion in the context of modern academic discussion, situating that within what we have with Techno-signatures and SETI and astrobiology. And then there's other hypothetical possibilities too. Is this another terrestrial source? Is this adversarial? Is this something else? I think those two things. So we need better instrumentation, but then also some more theory.
I have a couple of places to go with this. One is generally, if you sort of take aside the question of origin, it seems like we could maybe make some conclusions or we could investigate the potential of some kind of intelligence and or technology in association with these, craft or phenomena or whatever we're talking about. But another thing that you popped up there, which I think is really important, is this question of definition of evidence. So something that comes up, we were talking a little bit about the loose media headlines earlier. A very sloppy and sort of hand-waving from the other direction phrase that comes up a lot is there's no evidence that these things are extraterrestrial. But the unspoken subtext of that is, but we haven't defined what that evidence might be. So question for you, do you think that's a scientific project? How would we go about answering that question meaningfully such that at the end of a paper or a conference or whatever, we could say, if we saw these X characteristics or behaviors, we could reasonably define them as evidence that something might be extraterrestrial, or that it could at least be moving in and out of space. Does that sound like a project worth doing? Could it be something that a few people did, or would it have to be a bigger project? Over to you.
Yeah, no, absolutely, that is worth doing. I mean, if you have a headline that says there's no evidence that UAP are extraterrestrial, it's also correct that there's no evidence that they are not extraterrestrial, because we have very little data about them. They are unidentified. That's the whole point. So we don't know. We have almost no constraints. The only constraints we have is we don't know what they are, and they seem to be objects, and they're in the sky. That's basically all we know about them. So again, yeah, I think there's both an instrumental and a theoretical approach that we should be doing both of these at the same time. So one is collecting better quality control data, like you're doing with the Galileo Project and others, in terms of just capture some of these anomalies with good instrumentation so we can study them and better characterize them and see how different are these from the knowns. That will help us figure out what is an anomaly at all, and go from there. Depending on what you find, you may find something that's very difficult to explain using terrestrial processes. You may find that you learn something new about the Earth itself, but collecting better data to see what you're actually looking for is a big part of it. Now, from the theoretical level, we haven't done a good enough job as astrobiologists and SETI scientists in thinking about what would the signature of extraterrestrial technology be interacting around the Earth system. I gave some examples about, like, a spacecraft crashes onto the moon. We might think about it. So here's a sort of a thought experiment I gave to the NASA panel, and I've given this in other talks. So if there's a spacecraft from another star system coming toward the solar system, well, if we spot it around the orbit of Pluto, say, we would call it an interstellar object. That's what Oumuamua was, an interstellar object. Now, if it's a spacecraft and we can tell it's technology, well, we're interested. There's a spot in conventional SETI and techno-signature research for that, thinking about interstellar objects being technological. If this object makes it into the solar system and it crashes on the moon, it crashes on Mars, we call that a non-terrestrial artifact. And there are papers in the SETI literature that think about how would you look for something anomalous like a crashed spacecraft on a planetary body. And there are, a small number, but a couple of studies that have actually tried to do this with machine learning analysis of lunar imagery, high resolution images, and there's work to be done on that, but there's a place for it. But if the spacecraft then continues and it enters the Earth's atmospheres, now we call it a UAP, and it's off limits, and there's a dearth of scientific papers talking about this.
Yeah.
And so there's a need for theoretical grounding within the existing scientific literature for what would that look like? What would it be from a theoretical perspective? What would be evidence of extraterrestrial activity in Earth's atmosphere? How could we recognize that? What are a range of scenarios that would make sense for attributing something anomalous in the atmosphere to extraterrestrial activity?
Mm-hmm.
And I think if we had just a better understanding of that and grounded within, contemporary academic discourse, that would help both ground it in existing science and also help make a connection to the ongoing instrumental attempts to observe these things.
Really well said. I know you've been following the hearings in DC, so I want to mention one specific thing that happened in one of them in this context specifically. I like this one because it's findable on the internet. People can look for David Fravor's opening statement to the House Oversight Committee. What he says on this first page is that the air controller on their fleet ships had no idea what these things that they were observing were, but they had been observing them on their Aegis command system, combat system, for 2 weeks, and they'd observed these objects, quote, descending from above 80,000 feet and coming rapidly down to 20,000 feet, would stay for hours and then go straight back up, end quote. And that to me sounds like evidence of something. It's not proof that something is extraterrestrial, but if I were going to decide which column to put a tick in, like evidence against or evidence supporting, that seems to me like evidence supporting an extraterrestrial hypothesis, because it's, by some definitions, the edge of space. People still don't agree on where the space starts. Is it the Kármán line? Is it somewhere else? 80,000 feet might be a little low. Fravor says in his statement, that's basically the edge of space. But nonetheless, coming down from 80,000 feet, hanging out at 20,000 feet, and then zipping back up to 80,000 feet, observed repeatedly over several weeks on an advanced combat system, that's not evidence against extraterrestrial origin. So this is what sticks in my craw personally when I hear there's no evidence, because it's not proof, but it seems like it can't not be some kind of evidence. How do you feel about that?
Well, right. We cannot rule out the extraterrestrial hypothesis. I mean, I don't think we can even say it's probably not extraterrestrial. So, certainly, yeah, when you describe something like that, now maybe it's adversarial. Maybe it's something weird that the Earth system is doing. So we can't say that this is evidence that it is extraterrestrial. But as you say, that would also be at least, plausibly consistent with an extraterrestrial hypothesis. So, when I look at the historical record recently and, back to, Project Blue Book and James McDonald and things like that, Project Grudge, there's a lot of things that don't make sense and a lot of things you can easily explain. And then there's a bunch of things, smaller handful, but an important handful of things that you cannot explain easily, that are either something else new or adversarial or extraterrestrial. And what I take away from that is not that it must be extraterrestrial, but that there is a problem to be understood that we do not understand yet. Like the evidence, and you can maybe even use that to guide your instrumentation. So there are anomalies that people have seen, and they have showed up on radar and infrared cameras and optical cameras, and there's radio waves, and sometimes there's maybe radioactivity associated with them. Okay, you can use all that to develop your instrument sensor suite, because those are the observations that have been anomalous. But to me, that all tells me there is a problem. There is something to be observed. And until we understand it better, all the hypotheses have to be on the table.
Thank you. I want to maybe shift gears slightly into considering some of the more personal aspects of this situation. And I have two questions about that. One, staying close to this evidence and curiosity and validity of investigation, I wonder how it feels for you as somebody in the scientific community, especially the astrobiology community, to navigate this space of tension, which you alluded to earlier, because there are folks out there, not just from the sidelines, but inside the scientific community, who still have a really hard time with this idea, just from an investigation standpoint. Like, forget what we've discovered or not. There are people who don't want us to try to get more information. They think it's a bad use of time and resources. I guess, one, I should phrase that as a question. Is that true? Am I understanding that correctly? Is there still a big chunk of the scientific community that thinks we shouldn't be investigating UAP? And how do you feel about that? And then what, if anything, do you think we can do to evolve their perspectives?
I think it is still true. I think, since the, Pentagon reports and the declassification of the Navy videos, and then now the congressional hearings, there's been a bit of a softening of that approach compared to what we saw in previous decades. So when I go to an astrobiology or an astronomy conference and I say that I think that UAP are an interesting scientific problem and that it's worth studying, and even that we can't rule out the extraterrestrial hypothesis, I don't lose my job. I don't lose credibility. I don't have people, ostracizing me. So that's good. There may have been a time in history where I would have had stronger pushback and my career would have taken a hit. So in that sense, there's more receptivity to people who are scientists who want to just treat it like another scientific problem. Now, I think if you started opening up the NSF funding faucet and diverting money away, there might be stronger opinions. I think it's one thing for a scientist to take a personal interest in a topic and receive private funding for it, which I don't get funded for this right now, but something like the Galileo Project to build their instrumentation, that's one thing. But if there was public funding going there might be more of a pushback. That's just a guess. But my approach is in reach. It's talking to other scientists, just pointing out that this is an interesting scientific problem. There's a thing in the atmosphere that we can't explain. If it's really that we just don't understand how our sensors work well enough, that seems like an important scientific problem too. Mm-hmm. If something that clouds do that's weird that we don't understand, well, that seems more exciting than a lot of science going on at this conference here. Whatever it is. Then if it's something more important, then we should be even more excited about it. So that's kind of how I approach it, is just talking to other scientists about this like another scientific problem. I don't put any weight in the extraterrestrial hypothesis being more likely, but then I emphasize that because we don't know, you also can't say it's probably not aliens. We just don't know. We should study it. Whatever it is, it's important to understand.
I just want to note on a personal level, I see you straddling this fence, and I want to commend you, because I think it takes a certain kind of personality to live in this difficult space where you're holding yourself open, but you're sort of like rigorously agnostic. It's challenging because there's a gravity on both sides. There's sort of a gravity to shut it all out, and there's a gravity to go all the way down the rabbit hole. And it's admirable and difficult. So I just wanted to applaud you for your careful sort of central stance.
I appreciate it. I'll say that what helps is actually studying the philosophy of science. Not just being a scientist, but thinking about, what does science mean? What does it mean to do science? How do we know things? And so when you Karl Popper is one of my favorite philosophers. He has done a lot of digging into just epistemology of science. And even, to summarize his work, you can't ever prove anything. What you can do in science is falsify hypotheses. And then science is always a working state of knowledge. We always have the best working tentative hypotheses, and then you can always prove something wrong, but you can never really prove something to be true. And so that helps me live in that space. And that's what makes science exciting, is we know it's not true. And then we're left with a bunch of tentative truths, and we have to keep pushing those forward. And that's how we learn things. And so from that perspective, yeah, all the problems should be on the table. It's up to you as a scientist to decide where you want to focus your energy. There's certainly lots of examples of dead ends in science, but that's your goal. You asked me earlier about assembly theory. Now, there's scientists who think that's important. That's their personal choice to decide to invest their time, and then if you get funding, go for it. And I could be wrong. Maybe that's the next biggest breakthrough that's really going to help us find extraterrestrial life. And so there's some of that personal subjectivity in terms of prioritizing what investigations to do. But it should all be on the table. Nothing should be off limits. And if we don't know something, then we should be willing to find out.
I think to that point, I really like the ruling out sort of framework there. It's one of the reasons I use what must we believe as my sort of intellectual touchstone for this project is I like the clarity and certainty of limiting things as we get more definitive information. And in 2021, the Director of National Intelligence report, for me, took off the table. It falsified the hypothesis that UAP were all non-physical or imaginary.
Right. Objects.
Yeah, objects. So that's one of the reasons I keep UFO in the mix. I think there are some objects in here, and it's important to recognize that. And then it does not falsify the hypothesis of adversarial tech, and it doesn't falsify the secret US tech hypothesis either, although it says we don't have evidence for either of those hypotheses. But as you have pointed out, it also critically does not falsify the extraterrestrial hypothesis or some other kind of non-human intelligence. And it does say that some of these things suggest that there are technological elements at play here in some of these physical objects, which is that's not a hard rule out or in. It's a middle bucket.
That's right.
Yeah, go ahead. Did you want to?
No, that's right. No, I agree with all that. Yeah.
Okay, cool. I wanted to, I guess it's in this zone. It's another sort of personal question, but it's about the bigger structural forces. If we find out in the next 20 years that the military of some countries, say especially the United States, has in fact had much more information about this and information that would definitively change our scientific worldview, but they kept that secret. Would that bother you? How would it make you feel as a person and as a scientist?
Yeah, it would bother me. I mean, as a scientist, I want to know what's going on in our world, in our universe. And so, yeah, if as an astrobiologist, I'm looking at where is life, what's the distribution of life in the universe. And if it turns out that there's evidence that the military has been keeping secret from us, of course it would bother me. And if it's not related to the extraterrestrial hypothesis, but it's still something else, yeah, of course. I mean, the pragmatic part of me would then try to understand, okay, what was the reason for this? Was there some national security reason for keeping us in the dark? So, I mean, I guess I would try to understand at least the motivation, but yeah, of course, I want to know what's going on.
And I guess a corollary question, but in a more fun, positive light, is if we do find out that UAP are some kind of non-human intelligence, which is at least a possibility, if we do find that out, what do you think we should do?
Well, it really depends what we learn about them. I mean, I'm not necessarily worried that, if UAP were extraterrestrial and they were here bent on destroying us, well, they haven't done that yet, and so they're either not going to do that or they're highly incapable of it, because it's been a while. So short of that, yeah, I don't know. I think it would really depend on what it is that we learn about them. I'll entertain one scenario. If we learn that they are extraterrestrial, we somehow gain, strong confidence in the extraterrestrial hypothesis, but we can learn nothing more about them, and then they disappear. We learned okay, there was a visitation, they flew around here, they were observing us for whatever reason, and then they're gone. And all we are left with is the knowledge that we're not alone in the universe. There is extraterrestrial technology, and we can't say very much else about that. So that rules out any form of contact, any form of diplomacy or whatever you like to call it with them. That would greatly accelerate astrobiology and the search for techno-signatures, and that would place in all academic disciplines and all government discourse the knowledge that we are not alone is now something that we have to consider. It's not speculative. We may not be feeling like it's a threat. We may not even feel like it's something that is an immediate problem in this one scenario I'm entertaining, but it would then be something that is a reality. It would go from pure speculation and pure hypothesis to a reality. And so then the search for techno-signatures becomes something that is not just theoretical. We would have a data point. We would have, astrobiology would have 2 data points. Even if we don't know much more about that second one, we know we're not alone. So then how do we search for what else is out there? Then these other questions about implications for society and for politics become much less academic. They become more real, even if it's long-term planning and it's not immediately affecting our economy or our elections or something like that. It would be something that would not be on the fringe. It would remove the taboo. It would make this just part of mainstream discourse. And I think that would still be pretty significant.
Agree. And I like this hypothetical space. So I'm going to ask another.
Sure.
If we figure out that they're technological, if we can determine good evidence that we're looking at technological items, it seems to me that until we communicate, we still won't be able to definitively rule out adversarial tech or even secret US tech or, breakaway civilization tech. Not a huge fan of that theory, but it's out there. So do you think it would be a natural extension of the work of METI to attempt to communicate to any kind of local technological items, objects, craft, if we determined that they were in fact technological?
It's worth a try. Yeah. If we were to find that, then there's a place for local METI. And absolutely. I mean, it could be a long shot, but it would be more reasonable than METI efforts up to this point, where we would actually have a target to look at. And another possibility is we talked about we're ants and they're just flying by. Maybe they don't care about us. A lot of technology on Earth has advanced through mimicry, just the knowledge that something is possible. Jared Diamond wrote the book Guns, Germs, and Steel, and others have pointed this out too, that writing was invented independently in multiple places on the world. Like the Chinese writing and Western writing systems developed independently, but it's entirely possible that the idea of writing emerged once, and somebody who was, if it came from China first, somebody visited China, they came back to Europe and said, oh, they're doing this thing where they put symbols on tablets or paper and it means things. And sometimes that's all you need, is the knowledge that something is possible. So if we don't learn much else, but we learn that there's some other way of doing space flight, and all we do is just better characterize these objects and then they're gone, we may advance our technology just by the knowledge that that kind of space flight is possible.
Yes, that sounds like a really interesting avenue. And the more broadly here, first of all, just monkey see, monkey do. I think it's hilarious.
Right.
That's such a profound statement about humanity. But second, I think as I've gotten deeper into this subject, it's changed from me from expecting that one day we'll have all the answers to gradually realizing that we're going to get more information as our technology evolves, as our science deepens. But it's not going to be like a light switch. We're going to learn more. We're going to have better sensor data. We're going to probably get more video. but there won't be some day where we just figure it all out. It'll be a long continuum of learning more and experimenting ourselves. And I just wondered if you have any thoughts about what that spectrum might look like, or how we can kind of gird ourselves for the long haul, to your point about intergenerational projects.
Right. No, I mean, science is a process of discovery. And the historian Stephen Dick I mentioned, he's talked about this. You could ask yourself, when did we discover Saturn? It's like, well, ancient people saw Saturn as a point of light in the sky, but then it wasn't until the invention of the telescope that we resolved the disk of Saturn and learned about the rings and realized that, okay, Saturn is more, it's a planet that's different than the other stars. But it wasn't until, the space age where we actually sent probes to Saturn to better characterize it. It wasn't until very, very recently that we got a good image of the innermost parts of Saturn's rings to be able to characterize the physics that leads to the ring structure. So when was Saturn discovered? Like, there wasn't a when. It's an ongoing process of discovery and learning more and more about Saturn. And that's how all science works. It's all an ongoing process. Now, there sometimes are abrupt points in that discovery. Like we've got a new data point that overturns a lot of things we used to think. So it can be kind of jagged and irregular at times, but it's still a process. And so, there could be exciting developments with UAP where maybe the Galileo Project finds an anomaly and we've got, the best data ever on one of these things. And we propel forward, at least in a big chunk, what we know and how we're going to study these things. But then it's still a process to continue from there. So I think it's definitely going to be a journey that we're on and not an instantaneous discovery.
It's interesting to think about what might actually happen in that case. Like, you get great data from Galileo. Does that increase support for other orgs? Does it mean maybe more people will apply for grants from NSF and NASA and start sort of triangulating in on this data and just gathering more information? How much of that information will we need before we reach some threshold of? I've been thinking a lot about the idea of a consensus of curiosity among scientists that this is worth investigating, and it seems like we're moving in that direction, but we maybe haven't tipped into full majority enthusiasm yet.
That's right. The astrobiology program owes its origin to the Allen Hills meteorite that was from Mars, found in Antarctica, and there were scientists who analyzed this, and they claimed that there was evidence of microfossils on this meteorite that showed evidence of ancient Martian life.
Okay.
President Bill Clinton actually made a national address about this discovery, that there's possible life on Mars. They used careful language. They did not say we have proven life on Mars, but they said this is very compelling evidence, or whatever language they did. And based on that discovery, there was money allocated to start the NASA Astrobiology Institute. Very few, if any, scientists today consider that meteorite to be evidence of life on Mars. It was hotly debated and pretty widely falsified that those are microfossils. And yet we still have astrobiology today. So that was a specific discovery that led to much greater attention in the scientific problem. Even though that specific discovery didn't pan out, we now have a very robust astrobiology program worldwide.
That's a great example of how this can work. Well, as we start to round toward a conclusion here, I wonder if there's anything that you'd like to sort of put a gloss on, anything you'd like to return to or help correct in my thinking, or just put on the table at this point in our scientific investigation. Do you have any sort of concluding thoughts or things you think we maybe haven't touched in this conversation that would be worth bringing up?
It's been a great conversation. If you're out there listening and you want to fund UAP research, that's definitely needed. So I'll put a plug in for that. But, if you're a scientist or anybody really, for scientists in particular, I think we should not be afraid to take intellectual risks. I think that's important, but that could extend beyond scientists to anybody, depending on what your involvement is in this. There's obviously been historical stigma on the topic of UFOs, UAP. I mentioned the idea of just looking for techno-signatures in the solar system. We should not be afraid of what we might learn. We shouldn't be afraid to take intellectual risks. The worst thing is you learn nothing. But the best case is you investigate something that others were afraid to do. And then, maybe speaking to a different segment of people who may be listening to this, a lot of people want it to be extraterrestrial. And, a lot of people aren't scientists. They're not reading Karl Popper. They're not thinking about it. And so maybe just understanding that in science, admittedly, there are some people who are resistant to the idea. But beyond that, science has to be very careful. We can't embrace a conclusion just because we like it. And so there's a little bit of that too, is science is tedious. It requires patience. And so as much as you may want this to be extraterrestrial, wanting it doesn't make it true. And so we have to go about the slow, rigorous process of investigation, data collection, and analysis to figure out what's really there.
Well, thank you so much for sharing your time with us, Doctor. Would you like to point folks to a place they can find you online? They should check out your book, Sovereign Mars. But is there a social account you like them to engage with, or a website you'd like people to visit?
Yeah, my website is haqqmisra.net, haqqmisra.net. And I'm on X, formerly known as Twitter, at Haqq I'm on Facebook also at Haqq those are the best places. I definitely post updates on my papers, my interviews, and other things I'm thinking.
Well, thank you again so much. We're going to enjoy tracking you as we learn more information about this fascinating topic in the years to come.
Thanks so much. Really appreciate it.
And that's the show. Thank you for watching or listening. If you'd like to subscribe to the show, you can do that on patreon.com/WTUFO or on YouTube or on Buzzsprout. You can support us for as much or as little per month as you would like to. We really appreciate anything that you can contribute. Also, you can check out Spacefare's shop at spacefare.etsy.com. Thank you again for watching or listening. I hope you have a beautiful day.